Hello everyone, welcome to another session of Digital Forensics and Investigation. This session is based on iOS and Android devices. As you know, iOS is the leading operating system for tablets worldwide, and Android continues to be the leading operating system for the smartphones worldwide. So regardless of the sale and purchase statistics, if you are a forensic examiner, the chances are that you will need to conduct an examination of an iOS device or Android device. So, to perform a forensic examination of a mobile device, the examiner must know the internal components and inner working of that device. So, it is necessary to know the different models that exist and their internal components. So the following topics will be covered in this session, like the iPhone models and operating modes, password protection and potential bypasses, the Android iOS data acquisitions, and Android data acquisition. So the iPhone SE 7, 7 Plus, 8, 8 Plus, and new models remain very difficult when dealing with the physical forensic acquisition methods. So iOS devices, which is released after the iPhone 5, there is no method or tools which are available to physically recover data from these devices unless they are jailbroken. But the file system and the logical acquisitions can be obtained if the iPhone is unlocked. So before examining an iPhone, it is necessary to identify the correct hardware model and the firmware version installed on that device. So knowing the iPhone's details will definitely help you to understand the criticalities and also the possibilities of obtaining evidence from that iPhone. For example, in many cases, the device passcode is required to obtain the file system or logical acquisition. Even if the device is supported physically, the passcode is needed to decrypt artifacts such as emails and passwords. So depending on the iOS version, device model, and passcode complexity, it may be possible to obtain the device passcode using a brute force attack. So there are various ways to identify the hardware of the device. And the easiest way to identify the hardware of the device is by observing the model number displayed on the back of that device. The firmware version of the iPhone can be found by accessing the setting options and then navigating to Journal, About, and Version, as you can see on the screenshot. So the purpose of the firmware is to enable certain features and assist with the general functionality of the device. So the examiner must know the model number of the device. This is just to ensure that they have a proper tools and methodologies which can support that iPhone. So they must determine the internal storage of the iPhone as well to ensure that the evidence container is large enough for the entire forensic image. So most of the tools will not alert the examiner that there is not enough space available on the evidence drive until the space has run out. So this will actually waste time and force the examiner to acquire the device image again. And finally, the network capabilities of the device must be noted. So the examiner can properly isolate the device to prevent any remote access or wiping during the examination process. So it is important to know the different operating modes of an iOS device. So many forensics tools and methods require you to place the device into one of the operating modes. And most of the commercial tools will demonstrate the proper steps to get the device into a particular mode. So the examiner must understand what that mode represents. So iOS device can run in different operating modes like the normal mode, recovery mode, and the DFU mode. So some forensics tools require the examiner to know which mode the device is currently running on. So the first mode is the normal mode. So when an iPhone is switched on, it is booted to its operating system. And this mode is usually known as normal mode. And most regular activities such as calling, texting, and other activities on the iPhone performed on an iPhone will be run in the normal mode. So when an iPhone is turned on, it goes through the secret boot chain, and this does not occur for the jailbroken devices. So each step in the boot up process contains software components that are cryptographically signed by the Apple to ensure its integrity. The boot ROM, known as secure ROM, is the read-only memory, and it is the first significant code that runs on iPhone. So the boot ROM code contains the Apple Root Certification Authority public key, which is used to verify the signature of the next stage before allowing it to load. When iPhone is started, the application processor executes the code from the boot ROM. The boot ROM verifies whether the low-level bootloader, also known as LLB, is signed by the Apple or not, and then loads it. When LLB finishes its tasks, so it verifies and loads the second stage bootloader, which is known as iBoot. So iBoot verifies and loads the iOS kernel. Okay. The iOS kernel verifies and runs all users' applications. And the secure boot channel ensures that that iOS runs only on a validated Apple device. The second mode is the recovery mode. So during the boot up process, if one step is unable to load or verify the next step, then the boot up is stopped and the iPhone displays a screen as shown in the screenshot. So this mode is known as recovery mode. So the recovery mode is required to perform upgrades or to restore the iPhone. So to enter the recovery mode, we do the some actions on that. First, turn off the device. Then hold down the iPhone home button and connect the device to the computer via a USB cable. So the device should turn on. And continue holding the home button until connect to iPhone screen appears, as you can see on the slide. Then you can release the home button. So most of the forensics tool and the extraction methods will definitely alert the examiner about the current state of the iOS device. And to exit the recovery mode, simply reboot the iPhone device. And this can be completed by holding the home and power button together until the Apple logos appear. So normally, the process of rebooting returns the iPhone from the recovery mode to the normal mode. And the examiner may experience a situation where the iPhone constantly reboots into the recovery mode. This is known as recovery loop. So a recovery loop may occur when the user or the examiner attempts to jailbreak the iOS device and an error occurs during that process. So to get the device out of the recovery loop, the device must be connected to iTunes and the backup is restored to that on that device. The third one mode is the DFU mode. So during the boot up process, if the boot ROM is not able to load or verify the low-level bootloader, which is known as LLB, then iPhone displays a black screen. And this mode is known as Device Firmware Upgrade, DFU mode. So the DFU mode is the low-level diagnostic mode and is designed to perform firmware upgrades for the iPhone. So during a firmware upgrade, the iPhone goes through a different boot sequence, as you can see in the figure. So most forensic tool uses the DFU mode to perform a physical acquisitions on old iOS devices. So in DFU mode, the boot ROM boots first, which verifies and runs the second stage bootloader, which is IBSS and IBEC. So IBSS is a modified version of the iBoot that kicks off the IBEC loader and verifies and loads the kernel. So the kernel verifies and loads the RAM disk into memory. Okay, and Again, most of the forensic acquisition methods require the iOS devices to successfully enter into the DFU mode. And most forensic tools running on the Windows operating system will provide you the instructions how to enter that device into the DFU mode. Okay, so if you are examining an iPhone that runs iOS 8 or a newer version, and especially if it is a newer device, your chances to unlock that device are not very good at all. So there are some hardware-based solutions, for example, IP Box 3, but all of them works only occasionally, and using one of them can even result in breaking the device. So with iOS 11, this problem becomes even more severe, even if the device under examination is not passcode protected. So the examiner will need the passcode anyway, as it must be entered to confirm the trust between the device and your workstation. So what should a mobile forensic examiner do then? So use the lockdown file. The lockdown file, which is stored on the as a plist file on the trusted computer, it enables the examiner to trick the device into believing it that it is unlocked or a trusted forensic workstation. So you must be aware that unlocking with the lockdown file only works if the device was unlocked with the passcode at least once after its last reboot. So there are some advanced techniques that exist. So those advanced techniques include like fingerprint modes to trick Touch ID, masks to trick the Face IDs, and NAND mirroring to bypass passcode entry limits. So the first technique was first demonstrated by the Jason. So he showed how to bypass Touch ID by lifting another person's fingerprint with a common mold material such as a dental mold or a Play-Doh. And the second technique was demonstrated as a proof of concept by Vietnamese cybersecurity firm Bicao, and they created a mask that can be used to trick the Face ID feature using a combination of 3D printing, makeup, and 2D images. The last technique was demonstrated by Sergey, senior research associate at the Cambridge Computer Laboratory Security Group. This technique allows you to bypass passcode entry limits by soldering off the iPhone flash memory chips and cloning it. And this technique should work on any iOS device up to iPhone 6s Plus. Okay. So to effectively understand the forensic concepts of Android, it would be helpful to have a basic understanding of the Android architecture first. So just like a computer, any operating systems that interacts with the users and performs complicated tasks require an operating system to handle the task effectively. And this operating system takes the responsibility of managing the resources of the system and to provide a way for the applications to talk to the hardware or physical components to accomplish or perform some tasks. So Android is currently the most popular mobile operating system designed to power the mobile device. Android is an open source. Practically, this means that anyone can access it, freely modify it, and use the software according to the requirement of any device. So this is one of the primary reasons for its wide acceptance. Handling an Android device in a proper manner prior to the forensic investigation is very important task. Care should be taken to make sure that the unintentional actions don't result in the data modifications or other unwanted happenings. With the improvements in the technology, the concept of the device locking has effectively changed over the last few years. So most users have a passcode now as a locking mechanism, and it is enabled on their devices due to the increase in general security awareness. So it is important not to miss an opportunity to disable that passcode when there is a chance. So when an Android device which is to be analyzed is first accessed, check whether that device is still active or not. If it is active, change the setting of the device to enable greater access to that device. So when the device is still active, first enable USB debugging mode. So once the USB debugging option is enabled, it gives greater access to the device through ADB connections. And this is of great significance when it comes to the extracting data from the device. The location to enable the USB debugging might change from device to device, but it's usually under the developer option in the settings. So most methods for physical acquisition or acquiring Android device requires that USB debugging mode to be enabled. Then enable the stay awake setting. If the stay awake option is selected and the device is connected for charging, then the device never locks. Again, if the device locks, the acquisitions can be halted. Also, increase the screen timeout. This is the time for which the device will effectively active once it is unlocked. So the location to access the setting also varies depending on the model of the device. On a Samsung Galaxy S3 phone, you can access the same by navigating to Settings, Display, and then Screen Timeout. To isolate the device from the network, you can put the device into airplane mode and disable Wi-Fi as an extra precaution. Enabling airplane mode and disabling Wi-Fi works well, as the device will not be able to communicate over a cellular network and cannot be accessed via Wi-Fi. And also, removing the SIM card from the iPhone is also an option. But that doesn't effectively stop the device from communication over Wi-Fi or some other cellular networks. Okay. So now we will talk about the iOS data acquisition method. So first one is the logical acquisition. So a logical acquisition captures a part of what is accessible to the user. It means we won't get any deleted files. So a logical acquisition is the simplest way way to ascertain if the device is unlocked, as it simply uses the built-in backup mechanism. So most tools and the methods that support logical acquisition of the iOS device will fail definitely if the device is locked. So some things that if the device, if a physical image is captured, there is a little to no need for the logical acquisition. But not all the data is analyzed in the physical image. Okay, which is why having access to the logical image resulting in a readable data will assist in deep digging into the physical image for the artifacts to support forensic investigations. So a logical acquisition is the fastest, easiest, and cheapest way to gain access to the data stored on iOS device. So there are a variety of tools ranging from some commercial to free that are capable of capturing logical images. And most of these tools require that the device should be unlocked or access to the plist file from the host machine be easily available. The second type of data acquisition is the file system acquisition. So Secure Enclave has brought a new challenges to iOS forensic examiners, and now we cannot extract encryption keys required to decrypt the device images. So physical acquisition is useless. But here comes with the file system acquisitions. So unfortunately, it requires the iOS device to be jailbroken. Then we have the physical acquisition. So iOS devices have two types of memory: volatile memory and non-volatile memory. So the non-volatile memory is usually a NAND flash memory on the on the mobile phones. So volatile memory, which is RAM, is used to load and execute the key parts of the operating systems or applications. So the data stored in the RAM is lost after the device reboots. So RAM usually contains very important application information such as active applications, usernames, passwords, and even encryption keys. So although the information which is stored in the RAM can be crucial in the investigation, but currently there is no easy method or tool available to acquire the RAM kept memory from a live mobile phone. So unlike RAM, NAND is a non-volatile memory and retains data stored in it even after the device reboots. So NAND flash is a main storage area and contains the system files and user data. And the goal of the physical acquisition is to perform a bit by bit copy of the NAND memory, similar to the way in which computer hardware perform bit by bit copy of the internal hard drive. So while data storage seems similar, the NAND differs from the magnetic media found in a modern hard drives. So NAND memory is cheaper, faster, and holds a greater amount of data. So NAND is the ideal storage for the mobile device. Physical acquisition has the greatest potential for recovering data from the iOS device. However, current and the evolving security features on these iOS devices may hinder the accessibility of the data during the forensic acquisition. So researchers and the commercial forensics tools vendors are continuously attempting to develop new techniques to bypass the security features and perform physical acquisitions on iOS devices. Okay, so the next we have Android data extraction methods. So the first one is manual data extraction methods. So this method of extraction involves the examiners utilizing the normal user interface of the mobile device to access uh, contents present in the memory. The examiner will browse through the device normally by accessing the different menus to view the details such as call logs, text messages, and IM chats, for example. The content of each screen is captured by taking pictures and can be presented as an evidence. The main drawback with this type of examination is that only the files that are accessible via the operating system can be investigated, and care must be taken when manually examining the device, because it is easy to press a wrong button and erase or add some data to the device. So the manual extraction should be used as a last resort to verify the findings extracted using one of the other methods. Another one is the logical data extraction. So logical data extraction technique extracts data present on that device by interacting with the operating system and by accessing the file system. So these techniques are significant because they provide valuable data, work on most devices, and are easy to use. So logical techniques do not actually require root access for the data acquisitions. But having root access on the device allows you to access all files present on that device. So this means that some data may be extracted on a non-rooted device, while root access will open device and provides access to all files present on that examining device. So having root access to the device would greatly influence the amount and the kind of data that could be extracted through logical techniques. The next is the physical data extraction techniques. So the physical extraction refers to the process of obtaining and extracting bit by bit image of the device. So it is important to understand that a bit by bit image is not the same as copying and pasting the content of the device. If we copy and paste the content of the device, it will only copy the available files such as visible files, hidden files, and the system-related files. So this method is considered as a logical image. With this method, deleted files and the files that are not accessible are not copied by that copy command. So unlike logical extraction, physical extraction is an exact copy of the device memory and includes more information such as slack space, unallocated space, and so on. So Android data extraction through physical technique is commonly performed using DD command. Okay. While other advanced techniques such as JTAG and JPOP are also available, but those are usually hard to implement and requires great precision and experience to try them on a real device during any course of investigations. But extracting data through the DD command requires root access. So in the Android logical data extraction, we have three different options, like Android debug bridge pull data extraction, which is known as ADB pull data extraction. We also have SQLite Browser to view the Android logical extraction data. And then we have ADB Backup Extraction. So ADB is a command line tool that helps you to communicate with the device to retrieve information. So using ADB, you can extract data from all the files on that device, or just the relevant files in which you are interested. So to access an Android device through the ADB, it is necessary that the USB debugging option is enabled. From Android 4.2.2, due to the secure USB debugging, the host connecting to the device should also be authorized. So if the device is locked and USB debugging mode is not enabled, try to bypass the screen lock using one of the screen lock bypass techniques. So as a forensic examiner, it is important to know that how the data is stored on the Android device and to understand where the important and sensitive information is stored so that the data can be extracted accordingly. Application data often contains a wealth of users' data that may be relevant to the investigation. So the application data can be stored in one of the locations such as like shared preferences. So shared preferences stores data in key value pairs in the lightweight XML format. So shared preference files are stored in a share underscore prep folder of the applications directory, which is known as /data. Then we have internal storage. So this store data that is private and is present in the device internal memory. So files saved to the internal storage are private and cannot be accessed by other applications. Then we have external storage. This storage stores data that is public in the device external memory, which does not usually enforce security mechanism. And this data is available in the SD card directory. Then we have SQLite database. So this data is available in the database package, which is under data, and package name. So it is usually stored with the .db file extension, and data present in the SQLite file can be viewed using the SQLite browser or by executing the necessary SQLite command on the respective files. So every Android application stores data on the device using one or more of the preceding data storage options. So the contact applications would store all the information about the contact details in the data folder under its package name. Okay, so note it is also important to note that data directory is a part of your device internal storage where all the applications are installed under the normal circumstances. Some application data will reside in the SD card and also in the data partitions. So using ADB, we can pull the data present in this partition for further analysis using ADB pull command. Once again, it is important to note that this directory is only accessible on a rooted phone. Then we have the SQL browser to view the data. So SQL browser is a tool that can help during the course of analyzing the extracted data. So SQLite Browser allows you to explore the database files with the following extension like QLite, SQLite 3, .db or .db3. So the main advantage of using SQLite Browser is that it shows the data in the table form. So navigate to files, open database to open a .db file using SQLite Browser. So as shown in the following screenshot, there are three tabs: database structure, browse data, and execute SQL. The browse data tabs allows you to see the information present in the different tables within the .db files. Knowing the details of your Android device, such as the model, version, and many more, this will aid you to definitely will aid in your investigation. For example, when the device is physically damaged, and this prohibits the examination of the device information, you can grab details about the device by viewing the build.prop files, which is present under the systems folder. So accessing the call logs on the phone is often required during the investigation to confirm certain events. So the information about the call log is stored in the contacts2.db, which is located again in the database directory under data folder. Similarly, the mms sms.db file, which is actually present under the database location, contains the necessary details. So extracting browser history information is one task that is often required to be restructured by the forensic examiners. So apart from the default Android browser, there are different browser applications that can be used on the Android phones, such as Firefox Mobile, Google Chrome, and many more. All of those browsers store their browser history into the SQLite.db format. The file named browser.db contains the browser history details about the Android browser. Next, we have the ADB Backup Extractions. So starting from Android 4.0, Google implemented the ADB backup functionality, which allows users to backup application data to a computer using ADB tool. And this process does not require root access and can be very useful during the investigation and the forensic examination. The main drawback is that it does not back up every application installed on that device. The backup feature is application dependent. And as the owner of the application can choose to allow the backup or not. So backups are allowed by default, but the developer can disable it if he wants to. So the most third-party applications have this enabled, and the ADB backup command will work on for those applications. So once the command is run, the user then needs to approve the permission on that device. For this reason, if the device screen is locked, it is not possible to take the backup. The ADB dumpsims command allows you to gather information about the services and applications running on the system. The ADB shell dumpsys command gives diagnostic output for all the system services. The dump sys command does not require the root privileges to be executed and or require a USB debugging mode to be enabled, as we do in the other ADB commands. So analyzing certain dump sys services such as Wi-Fi user notifications and so on can be helpful in certain scenarios. Okay, so Android data extraction through the physical technique is commonly performed using the DD commands, while other advanced techniques such as JTAG and chipsoft are also available, but are usually hard to implement and require great precision and experience to try them on those real devices during the course of investigation. So extracting data through the DD command requires a root extract as discussed earlier. So the first is the imaging an Android phone. So imaging a device is one of the most important steps in the mobile device forensics. So whenever possible, it is imperative to obtain the physical image of the Android device before performing any techniques to extract the data directly from the device. So let's assume that a desktop computer, which is not powered on, and that is seized from a suspect and sent for the forensic examination. So in this case, a typical forensic examiner would remove the hard drive first, connect it to the write blocker, and obtain a bit-by-bit forensic image using any of the available tools, for example, FTK Imager. So the original hard drive is then safely protected during the forensic imaging of the data. With the Android device, all the areas that contains data cannot be easily removed. If the device is active at the time of receiving it for the examination, it is not possible to analyze the device without making any changes to it, because any interaction would change the state of the device. So Android device may have two file storage areas, like internal storage and external storage. So internal storage refers to the built-in non-volatile memory, and external storage refers to a removable storage medium such as micro SD cards. But it is important to note that some devices do not have removable storage medium such as SD card, but still they divide the available permanent storage space into the internal and external storage. So it is not always true that external storage is something that is removable. So when a removable SD card is present, a forensic image of the memory card has to be obtained. And these removable cards are generally formatted with the FAT32 file systems. Some mobile devices, device acquisition methods, will acquire the SD card through the Android device. But of course, this will slow down the process due to the speed limitation of the USB cable. Also, Android does not provide access to the internal directories and system-related files. This restricted access is to ensure the security of the device. For example, the data folder is not accessible on a non-rooted device. So this folder is important to us because it stores most of the user-created data, and many applications write valuable data into this folder. So to obtain an image of the device, we need to root the Android device first. Rooting an Android device gives us a super user privileges and access to all the data. And rooting is very common for the Android devices. But getting root access could alter the device in a manner that renders the data changes or wiped. So some Android devices such as Nexus 4 and Nexus 5 may force the data partition to be wiped prior to allowing any root access. So this negates the need to root the device to gain access, because all user data is lost during the process. So just remember that while rooting provides access for more data, when successfully done, it can also wipe the data and destroy the phone completely. So you must ensure that you have consent or legal rights to manipulate the Android devices prior to proceeding with the root options. So there are many tools available that can image a memory card, SD card. So here I will discuss the WinHex to create a raw disk image of the SD card. First, we need to connect the memory card, remove the SD card from the memory slot, and use a card reader to connect the memory to the forensic workstation. Then we need to write protect the card. So open the disk using WinHex, navigate to Option, Edit Mode, and then select Read Only mode, which is write protected mode, as you can see in the screenshot. So this is to make sure that the device is write protected and no data can be written on it. Calculate the hash values of the memory card to make sure that no changes are made at any point during the investigation. Navigate to Tools, Compute Hash, and choose any hashing algorithm, like MD5 SHA-1. Creating the image of the disk is then the last step. So navigate to File and then click on Create Disk Image, as you can see in the screenshot. So select the raw image options like .dd to create an image of the SD card. So this completes the imaging of the memory card using WinHex. Joint Test Action Group (JTAG) involves using the Advanced Data Acquisition method, which involves connecting to a specific port on the device and instructing the processor to transfer data stored on that device. So using these methods, a full physical image of the device can be acquired. And it is always recommended to first try out the other acquisition methods early, which just discussed now, because they are easy to implement and require less efforts. An examiner must have a proper training and experience prior to attempting any JTAG, as the device may be damaged if the process is not properly handled. In JTAG, the device test access port, which is known as TAPs, are used to access the CPU of the device, central processing unit. So identifying the TAP is the primary and the most important steps. And TAPs are identified and the connection is traced to the CPU to find out which pad is responsible for each function. Although the device manufacturer documents resources about this JTAG schematics of a particular device, but they are not released for general viewing. So wire leads are then soldered to the appropriate connector pins, and other end is usually connected to the device that can control the CPU. So as you can see in this picture, once it is set up, power must be applied to boot the CPU. So the voltage that must be applied depends on the specification released by the hardware manufacturer. So do not apply a voltage beyond the number which is given in the specifications. So after applying the power, a full binary memory dump of a NAND flash can be extracted. So analyzing the extracted data using a forensic techniques are tool. And then JTAG, you can say, may sound complicated, but the main advantage is that with this technique, uh, it looks very complicated, but it works even if the device is not powered on. So it does not require root access, ADB, or USB debugging. And it can be used to recover the device pins, passwords, and can image the entire flash memory and recover or crack password files. Then we have the chip-off method. So a chip-off, as the name suggests, is a technique where the NAND flash chips are removed from the device and examined to extract the information. And this technique will work even when the device is password protected or passcode protected, and USB debugging is not enabled. So unlike the previous JTAG technique, where the device functions normally after the examination, the chip-off technique usually results in the destruction of the device because it is more difficult to reattach the NAND flash memory to the device after the examination. The process of reattaching NAND flash to the device is called reballing and requires training and practice. In the chip-off technique, all of the chips on the device must be researched to determine which chip contains the user data. Once it is determined, the NAND flash is physically removed from the device, and this can be done by applying heat to desolder the chip. And this is very uh, delicate process and must be done with a very great care because it may result in damaging the whole NAND flash. So the chip is then cleaned and repaired to make sure that the connectors are present and in functioning order. So using a specialized hardware device adapters, the chip can now be read. So this is done by inserting the chip into the hardware device which supports specific NAND flash chips. And in this process, raw data is acquired from the chip, resulting in .bin files. The data acquired can now be analyzed using the forensics tools and the softwares. The chip-off technique is the most helpful when the device is damaged severely, or it is logged or otherwise inaccessible. So the application of this technique requires not only expertise, but also costly equipments and tools. So there is always a risk of damaging the NAND flash while removing it from the device. So it is recommended to try out the logical acquisitions first to extract any data. If that doesn't help, then go and try the chip-off techniques. So this brings us to the end of this session. Thank you very much.